Hi, my name is David Williams, and this Learning Byte is about BGP route flap damping. So we'll talk about route instability, the effect of damping on BGP routing, explain the default behavior of damping on links, control damping using the routing policy framework, and view damped routes using CLI commands. So the reason for damping is for route instabilities. Routes can appear and disappear rapidly. So the terminology is called route flapping or just flapping. A rapid sequence of update and withdrawn BGP messages. Every BGP router that gets an update or withdrawn message must propagate that to its peers. This can quickly cascade and affect router performance and, of course, consumes power and bandwidth. What damping does is it tells a router to ignore changes that occur too frequently. Reduce processor and protocol churn in the face of flapping routes. What are causes of route instability? Faulty circuits, IGP instability, human error, incorrect routing policy, congestions of links, and some routers have had problems with software, insufficient power, memory, or adding equipment. Route damping is the main BGP mechanism to control the route flapping effects. It is an RFC, it's RFC 2439, and damping applies only to EBGP sessions. It is ignored on IBGP sessions. So we'll start to look at some of the damping parameters. The first that we'll define is called the figure of merit. Figure of merit is a type of point value given to a route that becomes a penalty if it exceeds some value. All new routes get a figure of merit of 0, 1,000 points when the route is re-advertised. It costs 500 points when the path attributes gets changed. Points decay or reduce at a certain rate, which is called the half-life. If the points exceed the cutoff threshold, the route is suppressed. When points fall below a certain value, the route is then able to be reused. The maximum penalty imposed is called the max suppress value, and point value of given incidence, as we said, 1,000 points when the route is withdrawn, 500 points when the path attribute gets changed. So this is the definition of the damping parameters. There is the suppression threshold. By default, as you can see, it's 3,000. This is the value of the penalty when damping is initiated. The reuse threshold is where the penalty must decay for the route to be used again, and the default value for that is 750. The half-life is the decay half-life in minutes. Okay, it defines the time that it takes to reduce the damping penalty by half. The default value for this is 15 minutes. The max suppress is the maximum hold down time in minutes. So how long can we suppress route activity due to damping? The default is 60 minutes. So here we can see the graph that kind of shows how the figure of merit works. So here we have our route, and you can see that it's flapping up, down, up, down, up, down. You see our suppress threshold is 3,000. And of course, we have a decay rate, which is determined by the half-life. That's the time value, which is 15 minutes. As you can see, the route is flapping, and we hit above the suppress threshold. So now this route is going to be suppressed. this route will show up, or these routes will show up as a hidden route in the routing table. And you notice that over time, we get down to the reuse limit, which is 750. We can now bring the route back into the routing table. So to configure damping, by default, there is no damping configured. You must go under Policy Options, and you can use the default values that we discussed. So those would be the half-life is 15, max suppress is 60 minutes, the reuse is 750, the suppress is 3000, and you can turn it off for particular peers, for example. So you can say do not damp. If you want to change the defaults, you simply go under Policy Options, under the damping hierarchy, create a new damping profile, change your numbers, and then apply. Here's an example. Our objective here is on R1, we want to have some damping towards the internet, so we're applying a policy called Internet Inbound. On R2, if we simply turn on damping under protocols BGP, that allows us to use the default damping profiles. And then toward the customer, we have another import policy which is called Customer Inbound. So let's take a look at what those policies look like. Okay, so Customer Inbound, we're not damping at all. So we have a simple then action that says then damping, do not damp. We then have the Internet Inbound, which matches on particular route filters. Okay, and then we go down to the last one, which is do not damp, which has a disable. And then we have our aggressive damp profile. So as you can see, the question becomes, is this policy correct? Let's take a look at the policy called Internet Inbound. So what's wrong with this policy? As you can see from the match condition, we have 4 different route filters. The action is damping, and then the action then is do not damp. Because there's an action defined at the route filter, but it's not a terminating action, the then accept statement does not get evaluated, and it goes down to the second term, which applies the damping aggressive. The way to fix this policy is to have the accept statement on the same line as the from match condition in order to apply the terminating action at that point. So let's take a look at some of these command outputs. We're going to start out with doing show route damping history extensive, and this defines entries that have already been withdrawn but may have been logged. And you notice that when you say extensive, it tells you this particular route, the default damping parameters have been used, what the figure of merit was from the last update compared to now. And you notice that at the top, this shows up as a hidden route. Decayed routes are entries that might no longer be valid, but are not suppressed. So as you can see, when we look back up at the hidden output at the top, the route is no longer hidden, okay? So it's not damped at this point. It is decayed, however. And lastly, for suppressed routes, these are routes that are no longer being installed into the forwarding table or exported by routing protocols. As you can see, if you wish to clear these out, you can simply type in clear BGP damping. All right, so let's do a demonstration of route damping. In this example, we are going to use the default damping parameters. And so to enable damping is you just turn it on under protocol BGP. All right, so let's do a set protocol BGP damping and commit. And on our partner device, we'll go ahead and do the same thing. Set protocols BGP damping and commit. Okay. So now our next step is let's see how damping works. We're going to go ahead and remove a static route that we've redistributed into BGP. Okay, so let's see if we can find that in here. A whole bunch of stuff in the buffer.
Okay, so here we go. We're going to remove this static route. Okay, and then we'll commit. And then we'll go to back to our partner device, and we'll be issuing this command, run show route damping history, and we'll add detail to this. Okay. The first thing that you notice is that now we have hidden routes. Okay. So we're basically looking at the routes that have been withdrawn. Okay, so we're recording these routes. The route is currently hidden. There is a field, the merit, figure of merit value. Okay, so you notice that the number now has dropped to 1,000. And you can also see that we are now using the default damping parameters. Okay, so this command allows you to show routes that are withdrawn, but there still is a figure of merit. All right. So we'll go back to our device and we'll do another flap. The way we'll do that is just simply do a rollback 1 and commit. Okay, and we'll go back to our partner device. This time we'll do a run show route damping decayed detail. So what's different about this command and the history command? You notice the route here is no longer hidden. All right, so we can see that the route is now active. There is a field of merit, and you notice that it shows us that the figure of merit now, because the route has come back up, is increasing. All right, every time there's a flap, we get some points back. All right, so we can see the figure of merit between the last update and current. Okay, also just kind of shows you right here also that we're using the default damping parameters. So this command, what we're looking at is basically these are routes that have a figure of merit, but they're decayed. Now, what we can do if we want to really suppress some routes, what we can do is we'll go back to our partner device and we'll do a rollback 1. We'll do a commit. Okay, let's try it again. Get some good flapping going on. And maybe just one more. All right, now we'll go back to our partner device and we'll try a different command. This time it'll be run show route damping suppressed detail. Okay, so you notice we flap the route. Okay, these are routes that were damped because of the figure of merit. Okay, you notice too that because we flapped it so fast, we did all those rollbacks, that every time that we add the route back in, we add to the merit ceiling. And so even though the default figure of merit is 3,000, you can see that it's jumped up even over that because we flapped it quickly in succession. So we can see that this has basically been suppressed, okay, due to damping. It's currently a hidden route. And also the key thing, it tells us the reusable time. So this route has been bad. It's flapped actually flapped 6 times. And so we are going to wait 4340. Now, what if we don't want to wait 4340? Do we have any recourse? The recourse on this, you can do a run clear BGP damping. And now, as you notice, if we run our command again, it is cleared out. All right. So in summary, there's 3 commands that show you different states of damping. One is the show route damping history, which are withdrawn routes having a figure of merit. There's the show route damping decayed, which displays active routes having a figure of merit. And then lastly, show route damping suppressed are the actual routes that were damped because of the figure of merit. And again, to clear this out before the suppressed reusable time, you can run a clear BGP damping.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.